I'm basically going to be talking tonight about some work I did around my dissertation work with open public transit data. So first of all, who am I? I'm Nate Wessel. I just wrapped up a PhD at U of T in planning. All of it kind of built around open transportation data sets, and especially transit, real-time and schedule data. So that's what we're going to be talking about tonight. I know a lot of you have not worked with transit data before, so this is going to kind of be a high-level overview and a bit of a teaser for some of the things you can do with the great data we have here in Toronto. So first of all, most of the data that's out there for transit was really built around essentially trip planning. So this is, all of you should really know what this is. This is sort of an A to B Google Transit or Google Maps kind of, we are here, we want to go there, how do we do it by transit at a particular time? All the data, or most of the data that you see in transit is built around servicing this application. People want to know how they get somewhere at a particular time. And there are two basic data sets that are available for this. GTFS, or General Transit Fleet Specification. Who here has heard of GTFS before? Anyone? Okay, maybe. All right, good. So GTFS is essentially the transit schedule data. It's a set of comma delimited files that describe both the physical infrastructure of the transit agency, the routes, the stop locations, and so on, but also all the scheduled activity. Every single trip, every single time a vehicle arrives at a stop or a station, that's marked in the data. And so you can build this really sort of detailed mechanistic model of how transit works using GTFS. Now, the other big data source is real-time data. And in Toronto, we have that managed through a company called NextBus. A lot of cities have the GTFS real-time standard. This is essentially introduced because transit doesn't run according to a schedule all the time, as you probably realize. And the real-time data tries to update the GTFS, the schedule-based data, sort of on the fly in the very moment when you're making a query about how to get somewhere. So people quickly realized with all these trip planning applications that started coming out around 2005 that you could also calculate accessibility measures with these tools and these data sets. And in transportation, accessibility often has a bit of a different specific meaning where it's about measuring how useful transportation is for reaching some set of destinations from some origin or set of origins. And you can use an open trip planning application like Open Trip Planner, aptly named, plus GTFS, plus a lot of computing power, and you can essentially calculate or estimate travel times via transit from everywhere to everywhere in your city or metro, and produce some really interesting maps like this, which was produced by a friend of mine. So this is showing in Toronto how many jobs can you reach just by transit within a 45-minute trip. And you can see that a lot of things are going on here, but the subway is pretty important, and there are a lot of jobs in downtown. All of this done, by the way, with open data. Now, my dissertation came in looking at applying some of that real-time data also to these sorts of accessibility calculations. So we don't just have to look at the schedule, right? My idea was that in Toronto, if we just model accessibility using the schedule, you're going to have a lot of problems because things don't run according to schedule very well. So what I did was I built this tool that scrapes the NextBus API. The NextBus API has, it will report the location of every single vehicle in the TTC fleet, except for subways, which is at peak hour about 1,500 vehicles, and will report their location with updates every 20 seconds. It's a lot of data. Very high precision, too. essentially, what the tool does is it scrapes the NextBus API, gets all these vehicle locations and timestamps, pings it every 10 seconds, stores these GPS traces and breaks them into trips, matches those to the street or rail network, match the scheduled stops to the alignment of the route, interpolate the stop times, and at the end what you have is something that's really comparable to the schedule-based GTFS data set, which is usable in a lot of applications, like trip planning applications. So that's where the title of this presentation comes from, Retro-GTFS. Real-time data that's usually only used just in this very thin slice of time, just in the very moments where it's fresh, becomes actually an historic archive of past performance data. There's a link to the tool if anyone wants to check it out. It converts that sort of real-time NextBus data into a format that's really easy for you to dig into. How is transit doing at any particular moment, any particular place? It'll be relevant if I have time to get to this slide, that it also stores raw GPS traces with timestamps. Excuse my voice today, I'm getting over a cold. So with this real-time data, we can also look at reliability. And I think this is something that's really interesting. I've only really had the tiniest chance to dig into it with the data that I've been collecting and with this tool. So this is a little example of a study I did with some colleagues looking at travel times on the King Street pilot, now King Street Transit Priority Program, both before and after implementation. So in the top here, we have a plot of median travel times across the span of the day. Same on the bottom, this is the post-pilot version. Basically what we did was I selected out routes that were running on King Street through this corridor, measured the time where they passed this point where the program starts, measure the time they passed that point, look at the distribution variability in those times, and what you end up with is a really detailed and nuanced look at the change in reliability as infrastructure changes around transit. Now this is like not radically innovative stuff. If you're working in government, you have access to big data sets and all sorts of transportation reliability data, but this is done with open data. You guys can do this. If you have a bus that you use every day and you think it's not doing so well, you can actually test out how well it's doing and quantify it in really, really concrete ways. My slide is stuck. Okay, thanks. All right, I'm rushing through. This was another thing I did looking at reliability. I was doing a study looking at service on Lawrence Avenue for University of Toronto Scarborough. They were looking at how students can commute into campus and how reliable service was. So we used this data, this retrospective real-time data, to look at both wait times along the length of the route, and also total travel times, including wait times along the route. So this is essentially the route, stop by stop. UTSC is over here. If you're very close, most of your time is spent waiting. If you're very far away, most of your time is spent traveling and so on. But the really interesting thing is that you can see wait times increasing as vehicles go down the route, getting less reliable, probably bunching up. And really, really interesting is that we looked at the strategy you can use on this route. So this street has both express and local service. And we wanted to know, is it worthwhile to wait for the express bus, or should you take the local bus? And what we found was that it's actually not generally worth the extra wait time to let a local bus pass you to catch the express bus. So it really kind of undermines the purported utility of an express bus if the service is infrequent enough that the wait time kind of washes out any travel time benefit. Okay, really quickly. All right, I'm gonna skip a slide. Okay, so this retrospective real-time data lets you do accessibility analysis, lets you look at transit reliability, lets you do route choice modeling, especially using route reliability with really high temporal resolution, and really anything you can put your mind to. Like this data is open. You can collect it. The script is open source. You can just pull it down and really do what you want with it. And finally, Toronto has really excellent open transit data. My dissertation looked at every city that was using the NextBus API. There are about 40 agencies. Toronto's is the best. The 20-second update frequency is far and away the best. The precision is the best. We have GTFS coverage, that's schedule data coverage across the entire GTA. It's really good data. And if you guys are interested in transit, you should really check it out. Thanks for listening.
How do you measure wait time on that last graph? Were you out there with a stopwatch?
So the tool let me measure or estimate the arrival time of every vehicle at every stop. So what I did was I essentially assumed that people arrive randomly, which is fair because it's pretty frequent, and then just measure the difference between that and the next arrival.
So it's like the schedule versus the real performance. So that's the wait time is like how far off of the predicted performance that the real-time data was getting from the schedule.
So I didn't look at the schedule data for that plot.
Okay.
That was just what would your wait time be if you showed up randomly.
Okay.
But you can imagine it would be lower if you looked at the schedule data, which are perfectly even ways.
Cool.
Question: do you know if there is a similar tool for comparing the transit time for people's driving in actual real time in traffic?
You're asking about comparing.
Did you repeat the question?
Yeah, yeah. You're asking about comparing real driving times to real transit times?
Yeah.
I don't think there is a good open source tool. I know a lot of companies sell GPS code data. Essentially, when you use an app, your phone is selling all of your data for free, and companies resell that. You can use that to estimate driving travel speeds, but I don't know of any of it that's available to the general public without the price tag.
Just out of curiosity, do we share the user traffic data as well, like on different routes at different times?
Can you repeat the question?
Like user traffic, like how many people are?
Oh, how many people are taking transit?
Yeah, at the,
No, it's really interesting. This has been a big point of frustration for me. So I'm from Cincinnati, and we have kind of a backwards transit system there. But every single bus has what's called an automated passenger counting system. Over the door, there's a little camera that detects, bodies moving in and out, and it counts them up. And it can identify how many people got on and off at every single stop on every single trip in the entire network. And that's Cincinnati. Toronto TTC, as far as I know, does not have that, and certainly does not make it available, which is kind of a real shame.
even after Presto.
The machines have to work.
And you have to have Presto.
I'm not aware of anyone sharing that data publicly, and there's also a problem with that because a lot of people don't tap the second time if they make a transfer.
Okay. They don't tap off either in Toronto.
Yeah, don't tap off.
Just kidding. You said you'll be able to like map out on the actual route.
Sorry, can you speak up?
You mentioned something about like we were able to take that data and map our own route. How would we be able to input those data into? It's kind of like a map.
The GPS trace data, or like the GTFS.
Like we can just do this like on our phones.
Huh?
We'll be able to do this like from our phones.
No, this is an application essentially that I've built to run on a server that's connected to the internet, like scrape the data stored in a database, scrape the API for like weeks on end. It ends up being a really large data set. So it's not the easiest thing to work with, but if you know a bit of PostgreSQL or Postgres, where you want to map the data in QGIS, that's another good way of doing it.
When do you store the original data that you download from NextBus, or you completely convert it and toss away the previous data?
I do both.
Which one's bigger?
Definitely the raw data.
Raw data.
Yeah. There's a lot of points that end up just dwelling at stations for hours, and a lot of that gets filtered out when you actually convert it to GTFS. Yeah, it's a pretty big data set, but it's a lot of the same kind of data, so it compresses really well.
The NextBus API, does it give data only for TDC, or does it have data for like YRT or other, the GTA transits as well?
In the GTA, NextBus only covers TTC. I'm not aware if other regional agencies use another service to give real-time data. I'd be surprised if none of them had it, but they're probably using the GTFS real-time standard. If you check their website and search for something like developer data, you should be able to find that if it exists.
So I noticed with your King Street pilot, no longer a pilot, data, there's a big fuzzy middle.
Yeah.
I'm wondering if you can explain that and talk about how you maybe dealt with that issue.
Okay, excellent question. So this is just the raw GPS data, and this is where it goes crazy, right? And thankfully for the analysis I was doing, it kind of stops going crazy before the boundaries of the pilot project. Essentially, this is due to GPS error around tall buildings. There's a few other points in the city where it gets a bit wonky, definitely through most of downtown. But in general, dealing with error in the data, and there is a lot of it. There's a lot of points that end up, buses idling in Lake Ontario, and things like that. And the script that I developed does a lot to clean out those really obvious ones. But these ones here are mostly handled by using an algorithm to match the points to sort of a reasonable trip across the street or rail network. So by map matching it, I'm able to estimate the error associated with each point and sort of tamp it down to just King Street in this case.
I'm interested in like the open data format, like the GTFS, and done a PhD in urban planning. My question would be like, what are some other areas of urban planning where an open data format like GTFS could help with that specific thing? Like say like what's something that you feel like you would love to have something like GTFS, but for this particular thing that's maybe not translated.
That's a good question. I'll repeat it. Are there other open data sets like GTFS that could solve different non-transit problems? I'm pretty satisfied with how BikeShare has released a lot of their open data. The problem is that we really only get open data when there's like a business case to be made for it. And in this case, the real-time data helps people with phones, everyone's on phone. And so the transit agency sees it as a win. Same with the bike share data. I wish that phones were able to natively digest and shape files and let you scroll through them. And people did that in their free time. I know I would. Yeah, unless there's a business case for it, you don't really get open data of this quality and consistency and extent.
Have you noticed when you, I guess when you work with the TTC and with Metrolinx on this, have you noticed them using this data like in the feedback loop? So like the planning GO trains or like, you know, the Ontario relief line, like are they using this data to help with planning?
Excellent question. So I'll just repeat it. Is TTCs, Metrolinx, other agencies using this kind of data in their planning processes? Yes, absolutely. They generally have better data than we have available. In the engineering lingo, we would just call this AVL data, automatic vehicle location data. Agencies will generally store big databases of it, and they can run their own internal queries and see how lines are performing. This is how they generate performance metrics. If they have ridership data, it'll be tied into the same sort of system. What's really interesting about these open data sets, which again, they've kind of released for a different use case, is that we can begin to build that database ourselves as citizens and ask some of the same questions, or very different questions that they're asking, and see how our measures compare to theirs. So if they say, you know, TTC publishes reliability statistics for each line, and they are so bad. They're not detailed, they don't, it's actually the arrival time, or no, the departure time of a vehicle from its first stop or station. If it did that on time, then it's on time. Well, maybe you have a different idea about what reliability is, and you probably do. You can now see how reliable TTC is using data comparable to their own. Anyone else?
Have you took a look at whether this North American approach of buses leaving earlier actually reduces waiting times or actually increases it? Because as I'm from Europe, in Europe we are known to the buses rather be late than depart early, as in trying to give you the possibility to catch every possible connection on your route rather than departing earlier if there's nobody waiting at the bus stop.
Good question. So there's two basic paradigms in transit route reliability. In one case, with generally low frequency routes, like an airplane or an intercity train, you want it to be right on time. And it's better to be late than early, right? If you show up to the train station and your train to Montreal is not there, you're gonna be pissed. But on services like TTC operates on most of their lines, the service is frequent enough, you haven't bought a ticket for a specific trip. They just want it to be showing up frequently and at a steady rate. So that kind of highlights in particular why that's a silly performance metric for them to use. They probably know that another metric might not be quite as flattering. That's one suggestion.
Have you found any position data for the subway?
So there is a project ongoing with Civic